In this video, we'll get an introduction to two-dimensional plotting with MATLAB. Our objectives are to learn how to generate a basic labeled two-dimensional plot. We also want to become familiar with basic plot formatting commands and learn how to generate overlay plots and subplots. Of course, we'll talk about what those are as well. The main workhorse for plotting in two dimensions in MATLAB is the plot function. And this function generates a plot of the vector y versus the vector x. So obviously they must be equal length vectors. And the basic strategy for doing that would be to say if we want to plot a function, here's a function representing a damped oscillation. We would generate a vector x, and note I'm using the default for linspace. The default here is 100 elements, and 100 elements is usually enough so that we get a smooth line. Think about using a minimum of 100 elements when you want a nice smooth line in your plot. So we generate a vector x and generate a vector y, and then the plot command plots those and generates the figure. And always remember that the first argument is for the x-axis, the second argument is for the y-axis. So once we've generated that plot, usually we want to label it. At a minimum, we generally should include a title and axis labels. A grid is not necessary, but often helpful. The commands to add that are the title command, x label command, y label command, and grid command. And the basic format for using title, x label, and y label is just to enter your title as a string in the argument. We call that a string since it's in quotes, single quotes. So MATLAB adds, when we use those commands, MATLAB adds a title and x label for the x-axis and a y label. And then the grid creates the grid. The grid command creates the grid. So simple enough to create a basic plot. Sometimes instead of plotting a function where we want a nice smooth line, we might be plotting some data, for example, experimental data. We can also do that. We also do that with the plotting function. Here's an example from some tests of braking performance. So in this case, the way that we can plot those data points is by adding a format string in the plot command. So here's our format string in the plot command. And what that's saying is we want that plot to use diamond. The D stands for diamond markers, data markers. And the double dashes there mean that we're going to have a dashed line. And the R means it's going to be red. And so we get a plot with a dashed line and it's red. I've also shown here a way to control your font size for your axis labels and title. You just can add this option to the X label, Y label, or title commands to increase the font size and have explicit control over that. Normally you can just use the defaults, but sometimes if you're producing graphs to put in a report or something, you want to have explicit control over that font size. So let's talk more about that formatting string. So you might wonder, well, how do we know all the different options that MATLAB has for formatting? We can type help plot in the command window, and along with all the other information about the plot function, it will give you a table that lists available line types, colors, and data markers. So we have all these different colors, different data markers, and different line types. So for example, the plot string m plus dash dot would plot a magenta line with pluses marking the data points, and the line would be a dash dot dash dot dash dot line. And you can put these in any order in the format string that you send to the plot function. So that pretty much covers it as far as creating basic 2D plots. Let's look at some slightly more advanced plots. First we'll look at overlay plots. An overlay plot is when we have two or more data series plotted on the same axes. So here we're looking at that same damped oscillation that I showed earlier, and in order to add, what we're doing here is adding that red dashed line, these two red dashed lines, which represent the amplitude of the oscillation. And in order to do that, we can use the hold command. And the way to think about that is we can keep the current axes active. So normally when you plot, if you just plot multiple times, it'll keep overwriting the same figure in the same axes. If we don't want to erase the current plot and put a new plot on those axes, we can use the hold command such that our next plot commands, so here's our two more plot commands, they show up on the same axes as the first plot, instead of overwriting the first plot. And then we can add a legend. In this case, the legend, we just add the text using the legend command, and these are added in the same order as the original data was plotted. Another thing I've added on this slide is the figure command. The figure command gives you explicit control over the figure window. So when you use the plot command, it opens a figure window, and each time you use the plot command, it will open figure 1. But if you want to leave figure 1 open and open a second figure, you can use figure 2, etc. to open additional figure windows, and then to go back and control which figure window are you working on with your plotting commands. An alternative approach to generating an overlay plot is simply to list all of your data series in the same plot command. So here's a plot command. We have one data series for XY, one data series for X1, Y1, and one series for X and negative Y1. Here I've defined Y1 outside of the plot command. It's okay, up in the previous example, this is inside, so we can do math inside the plot function, or we can just define the vector outside the plot function. Either way is fine, but in this case we're plotting 3 data series in the same function. And this will work exactly the same as using the hold command. One thing I forgot to include here in the commands is to turn the hold off. You just use the command hold off, and then you'll be starting fresh on a new set of axes when you execute your next plot command after using hold off. Subplots are similar to overlay plots in that we're plotting multiple sets of data, but in this case we have multiple axes in the same figure window. And the time when this is good is if our y-axes are different orders of magnitude. So note these 3 subplots of some kinematics, or acceleration, velocity, and position of a falling object. Note the different orders of magnitude on the y-axis. So if we try to plot these all on the same axis, we wouldn't be able to see all three lines because, for example, the position is going up to 5 times 10 to the fourth, or 50,000, whereas the acceleration is constant at 9.81 meters per second squared. So that line, that constant line, would not show up on a plot of the position. So to the left it shows the commands I use to generate these plots. The one new command here, again we see the figure command, the one new command is the subplot command. And the way the subplot command works, let's rewrite it here. The subplot command is saying we want to generate a subplot with 3 rows of axes and 1 column. So the first 2 numbers in the subplot command in this example are what generate our 3 sets of axes for the plot. Then the third one is the current axes. So that third number specifies which axes are your subsequent plotting commands going to be acting on. So here we have subplot 311, and then all of these commands are working on the 311 set of axes. Subplot 312, then the next set of subcommands are working on the second. So here the 2 means the second row, or the second set of axes in that subplot. And then subplot 313, we go to the third set. And you'll notice here I only put an X label in the last set because since these all have the same X label, it would be redundant to include a label here and a label there. And that concludes our introduction to plotting. You'll get some more practice with the homework.